recorded. Okay, so I just want to make sure that the exam is going to be on Wednesday, right? Exam two going to be on Wednesday, um, April 2nd. Okay, so the starting time is 1:20 until 3:20, but you can always leave early after the exams, right? So I encourage you guys to have like a page of notes, right? A page of notes required. Okay. Uh, I mean, it's optional, but I want to make sure that you'll write enough notes before the exams so you don't just write all the questions from the exam review. And some question might not be on the test. So I actually just told you guys that the compounding interest rate would not be on the exam because it's kind of hard, and then I don't really have time to cover that part. Okay, but if I have time, I'm definitely gonna spend some time on it after the second exams. But like I said, it's still like we don't really have much time left. So I kindly ask you guys to ignore question number 12 because like I said, you don't necessarily have to evaluate the revolutions, like how many times it spins. It's not hard at all, but you have to convert it from inches to mile, and all of this takes time to get it done, right? So we skip question number 11 and question number 13 because those two questions, like I said, is not relevant to the second exam. Okay. So make sure you're gonna skip question 11 and question number 13. Okay. I will not give you compounding interest rate, but I might consider giving you the compounding interest rate on a final exam. It is a financial education at very important. So, um, okay. All right. So we should know like how to, uh, you know, uh, find the exponential functions given by a times b to the x. I might give you exact same question like this on the exam, except changing you know, some point instead of giving you 1, 4, 2, and I may give you like 1, 4, 3, and 16, and so on and so forth. You just simply plug that into the equation, and then we can solve for a and b respectively. So I won't be here that long because, you know, unless you have questions to ask. I think I went over that as well, correct? So you're gonna set up the f of one. So you're gonna plug in equal to 4, right? So you're gonna plug in x equal to 1 equal to 4. You can have f of 1 equal to 4. So you plug in 8 times b to the 1 power because we plug in x equal to 1. And then that's equivalent to 4. Okay. And then we can also start out with f of 2 as well, equal to 9. You can just plug in x equal to 2. You can have 8 times b squared, and that equal to 9. So just want to let you know that there are more than one way to solve for a and b. You don't necessarily have to follow one method. I think I went over that before. You can check back the notes on, we can check the notes uh, under March 3rd. I believe it's something, not necessarily. Maybe check the other notes. Yeah, we definitely learn how to sketch those functions. I think we did this question before, basically.
Yeah,
I just don't
my
remember like,
camera's not on.
oh, my camera.
Welcome.
All right. I just don't remember which date that we did. It might be on lecture. It should be around here for some reason, but I just don't remember. Yeah. Yeah, and then so then we can solve for the x and y based on that. So we can simply a and b we can just simply divide it. I prefer take the second equation divided by divide the the first equation, right? So we can actually get it solved quickly because like I said, we take the second equation over the first equation, you might end up with 8 times b squared over 8 times b, right? So by doing so, we can just find a ratio between you know a and b. So a got canceled, right? Obviously, that we can have like b squared would be just b on the right. So you basically have to keep the terms, which is so ab squared equal to 9. I'm gonna put 9 on top, right? And then over 4. How we go? So now we can just simply cross out the a, and then cross out the b. So b squared would be just b by itself. So we can basically solve for b equal to 9 for 4. And then we can plug that in. We can plug into the first or second equation, so it doesn't matter that much. We definitely going to solve for b. I'm sorry, we definitely going to solve for a based on the first equation. We have like 8 times b equal to 4. So just plug that in, right? Plug in b equal to 9 over 4 into so that we can basically just plug that in 8 times 9 over 4 equal to 4. And then essentially that we're going to divide both side by 9 over 4. And we can have a equal to 16 over 9. Okay. Well, this equation is not that bad. It's simply we have to, utilize the fact that we use 2 points and then we plug that in into the equation and then solve A and B respectively. So this is going to be the first question you have on the second exams. All right. So let's start with the second question. I believe second question and third question we did it before, so we can skip them, right? So let's do question number 4 and 5. All right, guys. So for this equation, we need to figure out the asymptotes, right? And then x and y intercept, and then we're gonna solve with that. So this question going to be really, really important. So you will be asked to find, the horizontal or vertical asymptote. So we know the fact that the exponential function doesn't have the vertical asymptotes. So when it comes to finding the vertical asymptote, all we have to do just set HA, sorry, the VA was none, right? Question? How many question? Um, yes, so definitely gonna post this notes on Brightspace as the exam review question. I think I mentioned that before. There are, I would say, 13 questions. The last class that we did, let me just go over it. Okay, so let me just if so let me compute 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I would say there are 15 questions. It should be less. It should be fewer than 15. I don't quite remember. Okay. I would say now email like the number of questions on the exam, but you know, you just have to focus for all of these. Um, you can read the notes as well. I think we done many of these questions before, except for like graphing. So the graphing question, I know we did it one time, but we still have to go over it. So for the horizontal asymptotes, we this one is very important that we have for any function, the exponential function without the constant. For example, we have like y equal to 2 to the x. So this one that is going to give us the horizontal asymptote, which is x equal to 0. Okay. However, if we have like -3, so the -3 going to be the thing that is going to make the function different from the original function. So this one we have to move that like 3 units on the y-axis, right? Because we're changing the y value based on -3 that we have here. So uh, I'm sorry, it should be y equal to 0. It's not. It's not x equal to 0. It's based on the y-axis, right? So we're just changing the y-axis by -3. We would have to move that like 3 units. So the horizontal asymptote is just it's just moving down to like -3 instead of y equal to 0. All right. So for the x and y intercept, we need to so for the y intercept, which is a little easier, that we're going to plug in x equal to 0 into the equation. So we have f of 0 here. We're gonna have like 2 times 0 plus 2 minus 3. So you have to plug that into the calculator. The exam question will be very similar to that. I'm gonna plug that into the calculator. I do have the virtual calculator right here, so we can do like like two to the second power minus 3, just one. All right. For the x-intercept, you're gonna plug in y equal to 0, and then you're gonna have like 2 to the power x plus 2. And I'm sorry, x plus 2 minus 3 equal to 0. Okay. And then And then we just plug that in. You're gonna move 3 to the right, so that becomes 2 to the power x plus 2 and equal to 3. And then we're gonna take log, so we're gonna take log both sides, right? Because that's gonna help us, solve the equation. So when you take log 2 both sides, and don't forget that we have to do it on both sides, so making sure that we have log 2 equal to 1. So log 2 3 it's just a constant, so you don't necessarily have to worry about that. We just simply get rid of log 2 in this case, and we get rid of it. Okay. So we end up with like x plus 2 equal to log 2 3. So that's the terms. And then we're gonna subtract 2 both sides and minus 2. Yeah, you just solve it. So we end up with x equal to log 2 3 minus 2. We can also take the ln as we did on the notes on the exam review. That's perfectly up to you. Okay. So this is just a number. You don't necessarily have to worry too much about that. If you want to plug that into the calculator. So the log 2 3 minus 2 should be negative like 0.415. You don't necessarily have to be too exact, but this one is less than 0. Okay. Because log 2 4 equal to 2. So 2 minus 2 equal to 0. So log 2 3 was something like, it's less than 2 for sure. Okay. So now the last step, you're going to graph the function, right? So the function going to have the asymptotes, right? It's simply the negative 3 right here. All right. And the next thing we have to remember is that the function going to have the one set. So with the one set, we just plug in x equal to 0, right? And then you just solve for y. So the value is fixed. So x equals 0, y equals to 1, right? And then when x equal to 0, y equal to x equals 0, y equal to 1. And then when x equal to a negative value, y equal to 0, it should be right here. And then we just graph a function like this on the exam. Upset with that. Just gonna go back. Are we good? Okay. Any question? Okay, so if the question also asks you about the domain and range, which makes sense to us, the domain is basically for any value of x, so we can start from negative infinity to positive infinity. Okay. The range of the function is simply about it from the lowest point, which is from the horizontal asymptotes. So we can just sort it from uh, -3 up to infinity. All right, and afterwards, that's pretty much it. I won't ask you anything further than this. So we're gonna label the intercepts, asymptotes on the graph. The function you can also look at the function by sketching it. So 2 to the power x plus 2. I'm sorry, we need x plus 2 minus 3. So we can literally check that the horizontal asymptote is on the line x equals to -3. I'm sorry, y equals to -3. I'm sorry with that. So we can literally check uh, this function. And then for the asymptote is from 0 to 1, and then also have like some log of 2, 3. -2 and 0. Okay. Well, you don't necessarily have to like label it correctly, but it should be something negative because we know the fact that log 2, 4 is 2. So, 2 minus 2 is 0. So log 2, 3 should be less than 2. So when you subtract them, it's negative. It's going to be positive if the curve going to go like this, right? All right. Any question? All right. Let's move up to the other question. You can also look at question number 5. So like I said, this one doesn't have a horizontal asymptote. So when you put it down, it's none, right? Obviously. So we're gonna, make sure that we don't have this. For the vertical asymptote, if you want to look back to the notes, it should be under on March something. We did this question before, 100%. No, we did not do that. Oh, we did the inverse function. No, actually. Yeah, don't forget about the notes on lecture 5, like March 10th. So we did this question. This is a very important question. Yeah, we actually sketched the functions on lecture 7, March 10 as well. So this is what we did. The exam should be very similar to that. So in order to find a first person, we're gonna put like x plus 4 equal to 0, and therefore we can have like x equal to -4. Okay. And then for the asymptotes, for the x and y intercept, so for the x intercept, we're gonna plug in y equal to 0. So we take log 3 x plus 4 equal to 0. minus 2 equal to 0. Okay, and then you're going to move 2 to the right, so that become log 3 x plus 4 equal to 2. And then, so in order to solve for this, we're going to uh, we're going to move the base to the right. So remember this. So you're going to move that to the right. So we have the x plus 4 equal to 3 squared. So I changed the marker for base because making sure that we know this is have to be going to the right. So we can solve for this. You can have x plus 4 equal to 9, and then therefore x equal to 5. We can also find the one-to-set by plugging x equal to 0. And then so we know the fact that the log 3 of 0 plus 4 minus 2 is just 4 minus 2. This is log 3 4, and this minus 2. Okay, so that is the one-to-set. So when you plug that in, so that will be 0 log 3 4 minus 2. So log 3 4 just the constant, just the value. You don't necessarily have to uh you know worry too much about that, but this one also negative. The domain and range, like I said, the domain is based on the the vertical asymptotes. So it should be around like from -4 to infinity. And for the range of the function, it's simply from -infinity to positive infinity. So there's no restriction for the range. So the range of function is can be any value. Okay, so and afterward, you just have to sketch the curve. So we're going to identify the asymptotes, right? The vertical asymptotes. So those, we need to make sure they're going to put that down first so we don't make mistakes on it. Uh, could you write out the stuff? Oh yeah. So first you're gonna plus two both sides. You're gonna add two both sides in this case, right? You're gonna plus two, and then and then and then you just move to and then we just simply uh you know and then move 3 to the right. So that becomes 3 square. And then you're gonna get x plus 4 equal to 9. And then you're gonna get x equal to 5. Okay. So for the x-intercept, you're gonna get y equal to 0, x equal to 5, y equal to 0. The hardest part is that you need to locate the one-intercept because this one's negative, right? So when x equal to 0, y is negative, slightly below it, and then the curve gonna go like this. So remember, it cannot go like positive. Let me just make it a little better. Remember, it's kind of path through this. If you path through like this, so you're gonna cut this one have to be below the axis, right? So it's gonna cut through it. And then just making sure that we draw it correctly, it has the asymptotes like that. All right, and that's pretty much what we have to do on the exam for this question. If you want to graph this, so we're gonna do y equals to log 3 uh x plus 4 minus 2. So this is how it looks like. It has a uh vertical asymptote, which is x equal to -4. Are we good? All right. Please ask question if you have any concern about graphing. Any questions? All right. So now we're gonna do one more. Then we're going to take the break, and then I'm gonna convert the video, and then we'll be back like around like like 1:10 or something, right? In 10 minutes. So I have to like take a break for this. Um, we, we, we're going to have a break for like 10 minutes, and then you have to log in again and come back to it. All right, let me just solve like question numbers 8. So question number 8 is a little easier. So the first thing we have to remember is that, well, when you have like given by the ln just log e, right? It's a natural log function. Uh, we don't necessarily have to worry too much about that. It's just a log function by itself. So, so when you have something like this, right? So we're gonna combine to a single log, right? A single ln. So when you have like addition, you're gonna combine to multiplications, right? So that you're gonna have a term ln of x plus 3 times x minus 2 equal to ln of 5x minus 1. And then you're gonna get rid of the ln because they both have the ln terms. And then we're gonna distribute that. So you're gonna get this one equal to x squared minus 2x plus 3x minus 6 equal to 5x minus 1. You simplify that, you're gonna get x squared minus x plus x minus 6 equal to 5x minus 1. And then we're going to subtract 5x plus 1 both sides. So we're going to set up the equation equal to 0. And then it turns out to be x squared minus 4x minus 5 equal to 0. So remember that on the exam, we should be able to factor it, right? We should be able to factor this one out completely, right? So we're not going to solve using, well, you can't solve it using quadratic form. It's going to take longer. We're going to get x minus 5, x plus 1 equal to 0. Okay, so we end up with x equal to 5 or x equal to negative 1. So the x cannot be negative because we take the ln of negative 1 minus 2 ln negative 3. You got like a undefined value, so you're gonna omit this. So make sure that x most likely not gonna be negative on the exams. All right, guys. So we'll be coming back around like one, like 2:10, and then you're gonna go over the other stuff, and then that's pretty much it. Okay, so we're gonna take a break like 10 minutes, and then we're definitely gonna come back to it. Make sure you're gonna lock in the Zoom again. Okay, and then you're gonna go over some of the trick, but the trick part that we did it from last class, so most likely covered most of this question, but we definitely have to spend times on the one question about the logs and one question about the half-life. All right, guys, so see you later.